In the Beginning by Dr. Walt Brown. Here are the proposals for the origin of Grand Canyon. There are 1, 2, 3, 4, 5, 6, 7, 8, 9 of these proposals. And if you notice underneath the hydroplate theory, they're all green. That means it all works perfectly. Red means it doesn't work at all. Yellow means is maybe. But you look under all the other proposals, it's mainly red and yellow with just a few greens. And you look under the hydroplate, and it's green all the way down. So let's go take a look at where the proposals would be. And let's see here. They talk about the proposals on page 231. But I don't want to know about the ones that don't work. I want to know about the one that does work, and that was the hydroplate theory. And that is going to be on page, let's see, what was this? Page 232. Walt Brown, 1989, the hydroplate theory for the Grand Canyon. The high-velocity floodwaters escaping from the subterranean chamber eroded massive amounts of sediments that liquefaction sorted into thin horizontal layers totaling more than a mile in thickness. By the end of the flood, those water-saturated sediments held about 20% of the floodwater. The groundwater that escaped years later sculpted much of Earth's terrain as we see today. Near the end of the flood, continent-sized hydroplates, still with some lubricating water below, accelerated downhill away from the rising mid-Atlantic ridge and toward the sinking Pacific plate. Within hours, the hydroplate met resistance and crashed. This compression event crushed, thickened, and buckled the hydroplates, quickly pushing up Earth's major mountain ranges. To see how fast, go to that page. Don't be shocked, just follow the evidence. All right, a series of major events then occurred which produced the Grand Canyon. The floodwaters drained off the suddenly thickened and elevated continents, leaving behind post-flood lakes in every continental basin. B, the newly formed Rocky Mountains settled into the mantle. They hydraulically lifted the Colorado Plateau. The Grand and Hopi Lakes, which average of lifted the Colorado Plateau and Grand and Hopi Lakes, an average of 6,200 feet above sea level. See page 236. C, a few centuries later, Grand Lake breached its southwest corner, causing Hopi Lake also to breach. The combined waters of both lakes and the escaping groundwater spilled off the western edge of the Colorado Plateau, swept off the soft Mesozoic sediment south and west of the lakes, the Great Denudation, and carved the Grand Canyon in weeks. Therefore, the Colorado River was born, a consequence, not the cause, of the carving of the Grand Canyon. To understand the Grand Canyon's origin, we must first explain some strange terrain features surrounding the Grand Canyon. The Colorado Plateau. Immediately after the flood, each newly formed mountain range began the slow process of settling into the upper mantle. Mountains have roots that descend into the mantle, a fact known for over a century. The hydroplate theory explains the forces, energy, and mechanism that sank those roots into the mantle and when it happened. The mass pushed aside by a sinking mountain range increased the mantle's upward pressure next to that range, causing the weakest portion of the crust to break and rise. Thus, plateaus rose next to the settling mountain ranges. Examples include the Colorado Plateau. Examples include the Columbia Plateau next to the Cascades, the Tibetan Plateau, the largest, highest plateau in the world, next to the Himalayan Mountains, the most massive and highest mountain range in the world, and pertinent to the origin of the Grand Canyon, the Colorado Plateau next to the Rocky Mountains. Considerable faulting and extreme frictional heating accompanied these uplifts. As a result, melting and volcanic activity occurred within each plateau. Large blocks, when lifted and tilted, became cliffs and mountains called block-faulted mountains. North of the Grand Canyon are many examples. Utah's Book Cliffs, Roan Cliffs, the Grand Staircase, Pink Cliffs, White Cliffs, Chocolate Cliffs, Vermilion Cliffs, Gray Cliffs, and others. As the floodwaters drained, continental basins became post-flood lakes, some quite large. The funnel. Imagine a post-flood lake with twice as much water as Lake Michigan, 5,700 feet above today's sea level, high on the Colorado Plateau. We will call this lake Grand Lake. About 15 to 20 miles southwest of Grand Lake is the top of the Echo Vermilion Cliff. Is the top of the long Echo Vermilion Cliff. Drainage into the lake from the higher elevations and possibly the breaching or even higher lakes increased Grand Lake's depth. Water drains from under Grand Lake, emerges as springs from the face of this 2,000-foot cliff system. Increasingly, the ground sinks along that drainage path between the lake and the cliff. Suddenly, Grand Lake breaches at a point on its bank and catastrophically erodes the soft Mesozoic sediments, forming a gigantic spillway, a steep 18-mile-long channel shaped like a widening funnel. Within weeks, large volumes of escaping high-velocity water erode the far end of the funnel to a width of 12 miles and a depth of 2,000 feet. Marble Canyon. The initially horizontal sedimentary layers below the floor of the funnel steadily arch upward as this downward erosion removes weight. Eventually, the funnel's floor, hard, brittle Kaibab limestone, cracks in tension, splitting open the entire floor parallel to the funnel's axis, forming Marble Canyon. Aquifers, porous water-saturated sedimentary layers cut by this deep vertical crack, rapidly spill their waters like large ruptured water mains into the newly formed Marble Canyon. Subsurface canyons draining into Marble Canyon begin to form. Initially, this underground flow is perpendicular to the canyon walls. Days later, the erosion of Grand Canyon removed so much mass that the deep layers to the south of Marble Canyon had to rise. This forced the underground flows near both edges of the newly formed Marble Canyon northward, so they merged with the water spilling out perpendicular to Marble Canyon, forming a hook-shaped or barbed flow pattern. Directly above these growing underground drainage channels, the earth sank, forming barbed canyons. Instead of sinkholes, we have hundreds of shallow sink valleys. See figure 31 and 132. For months, the underground channels were enlarged by all the sediments removed by the escaping water, so large underground pipes captured even more water. Eventually, only a few large subsurface drainage channels are spilling out at fairly even intervals among Marble Canyon. Also, water pouring out of the sides of the funnel spilled into some sink valleys more than others, eroding and deepening them so they capture more surface water and erode even deeper. Grand Canyon and the Kaibab Plateau. The south-flowing torrent of water spilled from Grand Lake undercut the northwest corner of Hopi Lake, elevation 5,950 feet, releasing its waters as well. Their combined waters, now sweeping westward over northern Arizona, first removed at least 1,000 feet of the soft Mesozoic sediments above the hard Kaibab limestone. As this weight was removed from almost 10,000 square miles south and west of the funnel. Deeper sedimentary layers arched upward, stretching and in many places cracking open the hard, brittle Kaibab limestone above. Near the breach point of Hopi Lake's high shoreline, a waterfall about 13 times higher and with possibly 100 times greater flow volume than Niagara Falls burst forth. The torrent from Hopi Falls, plus the flow from Grand Lake, sweeps away so much rock that the deeper rock must rise, not just directly under the deepening channel, but under the flanks of the channel as well. See figures 65 and 68. Explain this well understood engineering phenomenon, the buckling of the plate on an elastic foundation. The faster rock rises into the torrent, the more mass the combined flows sweep away. So deeper rock and the flanks of the channel also rise. A similar mass removal and lifting of the flanks take place along the southern flow inside Marble Canyon. It is clearly seen in the steeply tipped layers in Echo and Vermilion cliffs all along Marble Canyon. See figure 129. Therefore, the Kaibab Plateau is pushed up by the combined lifts west of the southern flow and north of the western flow. This channels and focuses the western flow through the lowest path, so even the more mass is swept away. Recall the Mesozoic layers had been swept off days or weeks earlier. Blocks of rock breaking loose and rising from so many different places under the Kaibab Plateau account for its steep, unusually hilly topography. For further insights into why the Kaibab Plateau rose and bulged upward, please see endnotes 145 and figure 153. About 20% of the volume of sediments on the rapidly rising Kaibab Plateau is subsurface water. The higher the plateau, rises, the greater the water's energy and eroding potential. For weeks, landslides, slumps, and mud flows spill down the rising slopes of the Kaibab Plateau from multiple directions. Powerful springs erupt from around the base and sides of the plateau. Many will flow without major seasonal variations for centuries, making Nankoweap an excellent habitat for humans for decades. Some drainage carves deep channels around Nankoweap Mesa, which is topped with earlier slumps, landslides, and rockfalls. Other springs carve Nankoweap Canyon, cutting through thick mud and slump deposits, exposing boulders stacked up to 200 feet high along Nankoweap's creek. Rocks and mud and water spilling eastward off the Kaibab Plateau can go no farther than Marble Canyon, which acts as a gutter, channeling and intensifying the southward flow. Thus, the land east of Marble Canyon is shielded from spillage off the higher rising Kaibab Plateau. Meanwhile, cascading waters from Grand and Hopi Lakes have begun to erode a 216-mile path to and down through the western edge of the Colorado Plateau. The deeper the waters cut below the high post-flood water table, the more high-pressure water is released from the flanks of the lengthening channel. Each sedimentary particle becomes a cutting tool carried by the rapidly flowing and falling water. As more sediments are eroded, more liquid sandpaper becomes available to erode more sediments. Additional energy is provided by the release of this mile-high subsurface water. In weeks, 800 cubic miles of sediments from the Kaibab limestone and below are removed, forming the Grand Canyon. Although Marble Canyon adjoins the Grand Canyon, their different shapes and widths earn them different names. The canyon's differences are explained when one realizes that the change occurs where the northwest corner of the higher Hopi Lake was undercut by the rushing waters from Grand Lake, where the Little Colorado River now joins the Colorado River. Simply stated, the waters of Grand Canyon helped carve Marble Canyon. No. Simply stated, the waters of Grand Lake helped carve Marble Canyon. The merged waters of both Grand and Hopi Lakes helped carve the Grand Canyon. Today, Grand Lake's basin is drained by the Colorado River and several of its tributaries, and Hopi Lake's basin is drained by the Little Colorado River. Both basins were once filled with silica-rich water that quickly escaped. Supporting evidence: mesas, buttes, spires, petrified forest, extreme meandering rivers, side canyons, and hundreds of huge pits excavated by powerful erupting springs will now be explained. Mounds, other categories are explained on page 217. Side canyons of Grand and Marble Canyon. Marble Canyon and Grand Canyon were rapidly cut thousands of feet below the high post-flood water table. Subsurface water, some traveling great distances, exited from the flanks of these canyons and may have exceeded the water in both Grand and Hopi lakes combined. That escaping water cut dozens of large previously unexplained side canyons that now enter Marble and Grand Canyons at the level of the Colorado River. Most of these side canyons have no appreciable water source today. If you are backward, barbed canyons. With all this weight quickly removed from the Grand Canyon region, the rock layers below rose, so layers north of the Grand Canyon sloped down to the north. Thus, subsurface water near Marble Canyon and the sink valleys above drained northward. Water spilling out of the funnel walls, Vermilion Cliffs on the west and Echo Cliffs on the east, flowed into and deepened the northward draining sink valleys, giving them the shape of the barbs in barbed wire. Although tributaries almost always enter rivers at acute angles, the barbed canyons are oriented at obtuse angles to the Colorado River. They are backward. Some barbed canyons are huge, a mile wide and 1,700 feet deep, where they enter Marble Canyon.